Hello students, this is Mr. Ravenscroft and I'd like to show you guys how to evaluate an exponential function. And these are given in function notation. That means they're using the f of x notation. And if you're on IXL, this is topic S.2 and it's shortcut LWE. That's the three letters that'll never change on IXL. So let's go through an example of this. First thing we need to be clear on is that f of x is actually talking about this function right here in pink. That's actually where you plug in a number for x, and then whatever this side turns into, whatever number that turns into, that's what the other side, the output, has to equal. This is what the output side is going to have to equal. So we plug in a number, whatever's on the other side, that's what the output is. Here's how this notation works. We'll actually call the input part, the pink part, f of x. That's actually like the machine. This is what we would call the f of x machine. So when I say, hey, take f of x, we literally mean take this part of the equal sign and rewrite it. But when they say, hey, I want you to plug in to the machine called f of x, I want you to go and where you see the x that's normally there, I'm changing the name. I want you to put a 4 there. I want you to find f of 4. What does that mean? It means take this machine, erase the x, and go plug in your x value. So I'm going to erase the x and plug in what they plugged in for x, which is a 4. So I take this x value of 4 and I put it right up there where x used to be. So they're basically saying, hey, what is this machine, what does this function equal when I plug in that x value? Well, f of 4 would equal, and we would say 4 to the 4th power. That's 4 times 4 times 4 times 4. I know 2 4s equals 16, another 2 4s equals 16. I happen to know that 16 times 16, if you type it in or work it out, you get 256. So what we could say right now is that f of 4 equals 256. If we were writing it as an ordered pair, we'd say the x value that we plugged in 4 gives us an output. We used to call it y, but now we call it f of x, or f of 4 if we want to be specific. F of 4 is equal to 256. But notice, we still have input and output. I want to explain this to you, the why behind what we're doing. And the reason we learn function notation is because sometimes we get lots of equations that all are measuring different things, and we want a way to talk about them a little easier. So just calling everything y is a little too simple. Saying f of 4 could be measuring something that starts with the letter f, such as how many frozen popsicles you've eaten today. Okay, probably something more important, but you get the idea. Let's type it in, and let's take a look at another answer here. 256 was our answer. Let's take a look at another example. Okay, moving a little bit faster now. You've learned the background. You've learned some of the notation. They want us to find f of 0. So there's the function we call f. You literally just take the x value, and they're telling you, I want you to plug in, where you saw x, I want you to plug in 0. So let's take that 5 times 7 to the, okay, it used to be an x there, but they're telling us to find 0, f of 0. So we go ahead and put a 0 right there where the x value is. So they said put a 0 in for x, we'll put a 0 there. Let's see what this side is going to equal, question mark. Anything to the 0 power is actually 1, so then we have 5 times 1, which is just going to be 5. So we can say that, hey, when you take the function, which is this thing over here, and you plug in a 0 for x, it ends up shooting out a 5. That would be our answer there. Let's type it in and see if we can find a little bit harder problem. Okay, in this example, we actually have a subtraction step happening after we plug in our value. No big deal. Let's try this. So where we see the x, we'll go ahead and plug in our value. They told us to, a 3. So 8 to the 3 minus 9. So f of 3 is going to equal, we just work it out. 8 to the 3rd, that'd be 8 times 8, that's 64. And then times one more 8. Let's see what we get there. We get about 512. So now we have, if we bring this down, 8 to the 3rd was 512. Let's see, minus 9, that looks like it'd give us about 503. Type that in. Let's do one last example here. Okay, in this last example, we have multiplication and addition. Looks like one more good problem to wrap up with. So let's write it out. Here we go. They want us to find f of 2, so we need to write out the function f of x, okay, 6 times 9 to the x plus 6. Now, if they want us to find f of 2, we need to go in here, and where we see the x, we can erase it, plug in our 2. All right, so we'll plug in a 2, and we got to work this out. Some students would mess this one up because they'd say, well, 6 times 9 is 54, and 54 to the second. Slow down there. What do you have 2 of? What does the exponent talk about having 2 of? The deal is exponents always, the whole world assumes that an exponent only applies to what's directly beneath it. Its base is only what's right beneath it. If they wanted it to include the 6, they'd have to put a parenthesis around the 6 as well. Since they didn't, we should assume it's really condensing down what would be 2 9s. There's 2 9s and only 1 6. So 9 times 9 will work that out, 81. Okay. And then order of operations says, yeah, multiplication is kind of like condensing something down. It's repeated addition. We have 6 81s repeatedly being added. So you might multiply those off to the side, work it out here. Looks like we get about 486. 486 plus 6, we could say we have about 500. 500 and, well, maybe not. 492. Working math out and talking isn't always my strong suit, but all right. Hey, we're going to wrap this topic up with that problem. We're going to let you guys try these yourself. Let me know if you guys have any questions. I'd be glad to help you guys out. All right. Take care. Love you guys. Bye-bye.